Okay, this lesson is about a concept called weighted average. Okay, a weighted average is not the same as a normal average. A normal average, what do you do with an what do you call that? Mathematical average? I don't know what the fancy word is, but a normal average is when you add up all the different parts and you divide by however many items there are. For example, here the daily average here is for daily grade, let's say 30, 50, 100, and 100. The total, we add them all up, it'll be 280. Yes? And then we'll divide by 4, which will give us our arithmetic median. No, not median. Is it median? No. Mean. No. Mean. Yeah, that's right. The mean, median, mode, yes. So this is the average for the daily parts, right? And then the quiz, if we had to average this, is 270 divided by 3, which is a 90 average. Yes? Okay, right? 100 plus 100 plus 70 divided by 3. So 270 divided by 3, which gives us 90. And then test average, if you scored an 80 and a 70, the average would be 75. This is the arithmetic mean of these things. Okay, this is not the weighted average. So to calculate your grade in this class, for example, if these were your grades, do you just add these 3 sections up and then divide by 3? Does it work that way? No. You can only do that if they're weighted the same, okay? But in chemistry, you know very well that it's not the same because daily average is only 20%. Quiz and tests, quiz and labs are 30%. And then your test average is 50%. Okay, so you can't just simply add them up and divide it by 3 because that's not weighted. When you do that, that's telling me they're all the same. They're all weighted a third, 1/3, 1/3, 1/3, but they're not. They're 1/5, 3/10, and 1/2. Okay, so they're weighted differently. So how do I account for that? What you need to do is take the average of each section. Okay. Take the average of each section. So change this weighted percent to decimal. So 70 times 0.2, that'll give you 14 points out of 20. 90 times 0.3 will get you 27. Okay. 50 times 0.75 will give you 75 times 0.5 will give you 37.5. Okay. Then you add all these up. Add these 3 up. So you add to get your final grade. Okay. Your final grade is 14 plus 27 is 41. 41 plus 37.5 is 78.5. Just trying to do that in my head. So that's how you find your average for this class. Okay. You need to multiply the average of each section by the weight, which is 0.2. Change the weighted percentage to decimals. Then 0.3, and then 0.5, and then add them up. It's different than just adding and then dividing by 3. Okay. It's not the same way. So what does this have to do with anything in chemistry? In chemistry, you have a periodic table in front of you like this, and these numbers down here, the atomic mass number here, these are all weighted average. Why are they weighted average? Because they average all the isotopes, the different isotopes of one element. Okay, it is the average of all the existing isotopes. And how do you calculate that? And so here's the way to calculate it. The steps. You need 2 things. The percentage of abundance. Abundance is how much of each isotopes there are. The mass number of each isotope of that element. A lot of times, most often, it's going to be whole numbers, but sometimes, depending on the different worksheet or different books that you look, some of them will have decimals in the mass number as well. Okay. Steps. Change percent to decimals by dividing by 100 or moving the decimal place 2 places to the left. Divide by 100 or move 1, 2 to the left. Multiply the mass of each isotope by the decimal to get the relative mass. So multiply each isotope mass by the decimal. Okay, then add up all of them to get your weighted average. Why don't we divide by 3 or by 2, by 5, however many elements? Because when you multiply by the decimal, it accounts for that already. Is that fraction that's already in there already. You don't need to divide anymore. Okay, so the way to do this is number 1, for example here. The mass of, let me zoom in a little bit here, just a tad bit. Oh, fancy. All right, the mass naturally occurring europium consists of 2 isotopes with a mass of 151 and 153. Europium 151 has abundance of 48.03%, and europium 153 has abundance of 51.97%. What is the average atomic mass of europium? So mass goes right here, the mass of the first isotope, which is 151, and the mass of the second one is 153. Okay, and now abundance. Change the two percentages to decimals, which is 0.4803 and 0.5197. Okay, that's step 1. Step 2, multiply them, and you'll get a fancy number here. Let me get my calculator ready. Clear that sucker up. 151 times 0.4803. 72.5253. 72.5253. Fine. And then do the same thing. 153 times 0.5197. 79.5141. 79.5141. Okay. So I get those two. Then now the last step is to add them together. So add them together. Get a calculator. 2.5253. And I get 152.0394. And the unit for atomic mass is atomic mass unit, AMU. Atomic mass unit. Okay. And later on we'll talk about the moles and we'll change it to grams. But as for now, it's atomic mass unit. Okay, you'll finish this paper and that's basically it. Oh, number 6. Number 6 is a little different here. You don't have to do a lot of work there. Boron exists as 2 isotopes, boron 10 and boron 11. Based on the atomic mass on the periodic table, which isotope is more abundant? So if you look at the periodic table, it looks like this. Boron. There's the periodic table. Boron's right there. The average atomic mass is 10.821. 10.821, right? Atomic number is 5. So if you look at this number here, and so basically, which one's closer, boron 10 or boron 11? And the answer is boron 11. It's closer. It's closer to that. So to get that average, there has to be more boron 11. Okay? To get the average that's closer, you have to have more of that. So boron 11 is more abundant because it's closer to the atomic mass. All right. So the more abundant one would be the one that's closest to the average. Okay. All right. That's it for this video. Goodbye.